All right, let's dive right into this explainer. Today we're going to visually unpack a fascinating thought experiment by João Carlos Holland de Barcelos. We're looking at a concept that directly challenges a classic, foundational cornerstone of physics. It's called the Jocaxian train. And it's an incredibly intriguing twist on one of the most famous mental exercises in scientific history.
But before we get into the heavy concepts, I really want you to ask yourself a question. Just imagine, could altering one tiny, seemingly insignificant physical variable in a famous experiment, like literally just cutting a hole in the floor of a train, could that logically unravel our understanding of an entire scientific theory? Keep that in the back of your mind as we go through this.
Okay, Section 1, the time dilation concept. So, to understand the author's twist, we first need to establish our baseline. And the absolutely crucial concept here is temporal dilatation. Special relativity tells us that the speed of light, represented by c, is the universe's ultimate constant. It never changes, no matter who's looking or how fast they're moving. Because the speed is totally inflexible, something else has to give when two people observe light traveling different distances. And that something else is time itself. Time stretches or dilates. Basically, the person who measures the shorter light path experiences a slower passage of time.
Moving on to Section 2, Einstein's classic train.
Let's see how this builds in a scenario you're probably already pretty familiar with. We've got two completely different perspectives here. First, we have an observer inside a moving wagon with a light source right next to them. And then we have the perspective of a second observer standing perfectly still at the station as that train speeds by. We're going to track the path of the light for both of them.
Let's break down exactly what's happening. Inside the train, the light source is stationary relative to the passenger. That person inside sees the light flash straight up to the ceiling, hit a mirror, and bounce straight back down. It's just a short, simple vertical path. But for the person outside on the platform, the train is physically moving forward while that light is traveling up and down. So they see the light travel a much longer, diagonal, zigzag path. Yet, and this is the kicker, according to physics, the speed of that light is identically fast for both of them.
This leaves us with a really stark contrast. The train observer measures a shorter light path, while the station observer measures a longer path for the exact same beam of light. Because the speed of light simply refuses to change, time must compensate. Time dilates for the station observer in order to maintain that constant speed over the longer observed distance. So the classic conclusion of this mental exercise is that the observer inside the moving train experiences temporal dilation. As the standard equation t is less than t prime shows us, the watch of the person inside the train is literally ticking slower than the watch of the person outside. This is standard special relativity, the stuff taught to physics students everywhere.
Which brings us to Section 3, the Jocaxian train twist.
Now that we have our foundation mapped out, let's introduce Barcelos' twist. By making just 3 simple physical modifications, he fundamentally changes the whole game. First, and this is kind of the fun part, we literally cut a hole right in the floor of the train wagon. Second, we take the light source out of the train entirely and place it squarely on the ground at the station, between the rails. And third, we keep the mirrored ceiling exactly where it is inside the moving train.
Think about this new setup for a second. As the train moves forward over the tracks, a flashlight sitting completely still on the station ground shines a beam straight up. That beam passes perfectly through our brand new hole on the floor, hits the moving mirrored ceiling, and reflects right back down through the hole to the flashlight on the ground.
Section 4, reversing the light path. So, let's trace these new paths. Think about our 2 observers again, the one inside the speeding train and the one standing still at the station next to the flashlight. With this new setup, who do you think sees the shorter path?
Well, the geometry completely flips. The person standing still on the station floor now sees the light go straight up from their flashlight, hit the moving mirror, and come straight back down to its source. It's a short, vertical, back-and-forth path. Meanwhile, the observer in the moving train sees the stationary flashlight approaching, flashing, and then receding. To them, the light forms a longer, triangular, zigzag path as they move past the stationary ground.
Applying the exact same rules of temporal dilatation we established earlier, we have to ask ourselves which observer's clock is logically running slower now. Remember, the rule is that the person who sees the shorter path experiences the time dilation.
According to the strict logic of the theory, because the station observer now sees the shorter, vertical path, they're the one who experiences temporal dilation.
Looking at the equation t is greater than t prime, time is actually passing faster for the observer inside the moving train and slower for the person at the station. The physical reality has completely flipped.
This leads us right into Section 5, a relativity paradox?
This brings us directly to the core argument of Barcelo's paper. When we put these two thought experiments side by side, the contradiction becomes incredibly apparent, right? In Einstein's train, time slows down for the train passenger. But in the Jocaxian train, time slows down for the station observer.
Let's use this table to really solidify the comparison. We have the exact same physical train moving at the exact same speed. We have the exact same observers in the exact same positions. Literally, the only variable that changed was the location of the light source. Yet the reality of whose biological clock ticks slower completely flips based solely on that flashlight.
Barcelos points out this logical contradiction directly in his paper. He writes, quote, "The same physical train and the same observers experience a temporal dilatation which depends on where the light comes from." End quote. He's emphasizing that time dilation in this mental experience doesn't actually seem to depend on the absolute motion of the train, but entirely on whether the light source is physically located inside or outside the vehicle.
So look at this fascinating scenario Barcelos has presented us with. In this framework, the fundamental physical experience of time for these human beings is dictated entirely by where a light bulb is placed. If the flashlight is in your hand, your time slows down. If it's outside, the other person's time slows down. The author argues this presents a profound logical paradox in restricted relativity.
As we wrap up this explainer, I really want you to actively ponder this. Think about the geometry and the rules of time dilation we just mapped out. Is this a genuine paradox, resting right there on the tracks of special relativity, completely flipping biological time based on a flashlight? Or, is there another piece of the physics puzzle we're missing here? It's absolutely a brilliant way to test our understanding of the universe, simply by cutting a hole in the floor of a train.